For our project, we created a database for an imaginary pet store called Petopia, the largest and most differentiated pet store in the world. Petopia is known as a one-stop shop for all of its customers' needs, as well as carrying a wide range of animals.
Our database will serve multiple functions such as tracking adoptions and pet medical history, as well as inventory, grooming, and kenneling.
It will also store information on every employee, customer, and supplier.
This will help consolidate Petopia's business into a manageable system.
Now we'll pass it back to Amanda to talk about how we converted the business model into an ER diagram.
After we decided on the scope of our project, the next step was to convert this business model into an ER diagram, carefully following Petopia's business rules. To do this, we first separated each business segment into its own entity. As you can see, manager, product, supplier, customer, pet, groomer, and kennel each have their own entity with their respective attributes.
In order to explain our ER diagram to table process at a sufficient depth, we have decided to focus this video on the entity in our diagram for pet and its relationship with customer and groomer. Because Petopia's business rules state that a customer may own many pets, but a pet must belong to one and only one owner, pet has a one-to-many relationship with customer.
For this reason, customer ID must become a foreign key in the pet table in order to uniquely identify each instance of pet. This makes sense logically because if we were to use this database to identify a single pet and the foreign key was not listed, we would not know the pet's owner.
Petopia has another business rule about its grooming service. The rule states that a groomer may groom many pets and a pet may visit many groomers. This means that pet has a many-to-many relationship with groomer. Because of this relationship, we must create an associated entity called pet groomer in order to uniquely identify each instance in which a pet is groomed.
After we finished designing the ER diagram and laying out our tables, we started the process of normalization. The goal was to reach third normal form for all of our tables.
The first step of normalization is to make sure each table has a primary key that can uniquely identify each instance in that table, and to remove any duplicate values. By paying attention to the cardinality of each relationship, keeping an eye out for the multi-valued attributes, and following the business rules, we guaranteed our diagrams table would automatically be in first normal form.
The next step is to remove any partial functional dependencies. Partial functional dependencies can only occur if there are composite primary keys. Because we designed all of our original tables to have a single primary key in the form of an ID number to uniquely identify each row, our tables are also already in second normal form.
You may have noticed that we have composite primary keys in the associative entities resulting from the many-to-many relationships. For example, our table Pet Groomer has a composite primary key composed of Groomer ID and Pet ID. However, none of these tables have attributes that are partially dependent on one of these keys. Instead, each attribute in this table is dependent on the composite primary key as a whole.
The last step is the removal of any transitive dependencies. Our diagram was designed from the start without transitive dependencies, so all the tables are now automatically in third normal form, and the normalization process is complete.